In this video we're looking at the 2022 Deferred question 1, which is a titration question. So in this question we are looking at ammonium iron 2 sulfate crystals which are used as lawn feed. So the question says, to analyse the iron 2 content of ammonium iron 2 sulfate crystals, 11.76 grams of the crystals were used to make up 250 centimetre cubed of solution. The ammonium iron 2 sulfate crystals were first dissolved in about 30 centimetre cubed of dilute sulfuric acid in a small beaker. The solution was then carefully transferred to a 250 centimetre cubed volumetric flask, and the solution was made up to the mark using deionised water. The resulting iron 2 solution was measured in 25.0 centimetre cube portions into a conical flask, and about 15 centimetre cubed of a dilute sulfuric acid were added, and the mixture was then titrated with the previously standardised 0.020 molar solution of potassium permanganate 7, KMnO4. Okay, we're just going to focus on the calculation in this question. So let's skip down to part D. So we're given the titration reaction here between the permanganate and the iron, okay? And we're told that in the titration 25.0 centimetre cube portions of the iron 2 solution made from the crystals required 30.0 centimetre cubed of the 0.02 molar KMnO4 solution for the complete reaction. And we're asked to calculate the concentration of the solution in the volumetric flask in moles per litre of iron 2. Then we're asked to work out the mass of iron 2 in the 11.76 grams of crystals used to make up the 250 centimetre cubed of solution. And then finally in part 3 we're asked to work out the percentage by mass of iron 2 in the crystals. So notice that I've underlined all the important bits of information in the question that we're going to need to answer E part 1, 2 and 3. Okay, so what we're doing here is we're analysing the iron content of ammonium iron 2 sulfate crystals. And we're doing this by titrating it against a previously standardised solution of potassium permanganate, KMnO4. So that means we know the concentration of the potassium permanganate, and we're trying to work out the concentration of the ammonium iron 2 sulfate. So let's start off, as we normally do in these titration calculations, with our balanced equation. And we're noting the reaction ratio of 1:5 for manganese, the permanganate anion and iron 2+. So let's pop that into our table. So in our table we have our permanganate ion, we have our iron 2+ ion, and we have the molar ratio, which is 1:5. So we get that from the balanced equation. And then we are just putting in the bits of information that were given in the question. So we're told that when we titrated exactly 25.0 centimetre cubed volumes of our iron, so that's going to be our volume of our iron, that we used 30 centimetre cubed of the permanganate solution, okay, and the permanganate solution had the concentration 0.02 molar. Okay, so let's just write in what we have. So we've written in our volumes, okay, for both the permanganate and the iron, and we can convert the centimetre cubes into litres by dividing by 1,000. We've also written in the concentration of the permanganate ion, potassium permanganate solution, which was given to us in the question. Alright, so the first thing we're going to do is we're going to work out the number of moles of permanganate, okay, and we're going to use our not very complicated triangle over here. We're looking for number of moles, so if I cover the number of moles, that's going to give me volume times concentration. Okay, so for permanganate, the permanganate anion, we have that the number of moles is going to be the volume times concentration, so that's going to be 0.03 litres, the volume times concentration, which is 0.02, okay. When we work that out, that's going to give us 6 by 10 to the power of -4, or 0.0006 moles. Right, that's our first thing we're going to work out. This then allows us to work out our number of moles of iron, because we know for every 1 molar of permanganate used up, we require 5 moles of iron to fully react, okay? So we're literally going to multiply 6 by 10 to the minus 4 times 5, and we're getting 3 by 10 to the minus 3 moles of iron 2 plus. Alright, the third step we're going to do now is we're going to work out our our concentration, I should say, of iron. So to work out concentration, using our not very complicated triangle, concentration is going to be number of moles divided by volume. So we have the number of moles, okay, so our number of moles is 3 by 10 to the minus 3, dividing that by the volume, which is 0.025, and we're getting a concentration of 0.12, and that's in moles per litre. Okay, so our table now that we've completed is going to help us with the next few parts of the question, okay? So we're asked to calculate the concentration of the solution in the volumetric flask, okay? In moles per litre of iron 2, okay? So let's take a look at that. Okay, so we have this written already, okay? We've worked out in this little section here, so simply we can just write that in. So the concentration of the solution in the volumetric flask in moles per litre of iron 2 is 0.12 moles per litre. So that's straight from my table, okay? So remember, this is the iron column, okay? Right, part 2. Now we want to calculate the mass of iron 2 in the 11.76 grams of the crystals, okay, that were made up to 250 centimetre cubed in the solution. Okay, so let's start off. So we know that the concentration of the solution is, the concentration of our solution is 0.12 moles per litre. Okay, but we didn't actually have a litre of this, okay, we only had 250 centimetre cubed. The 11.76 grams of the crystals were dissolved and made up to 250 centimetre cubed. So what I'm going to do is I'm going to divide this by 4, and that will give me 0.03 moles per 250 centimetre cubed. Okay, and back to the question, I'm being asked to work out the mass of iron 2 in the crystals. So I want to convert from moles to mass, and remember using my good night Mr. Tom triangle in order to work out grams. I cover grams and I'm left with number of moles times relative molecular mass, or relative atomic mass in this instance, because iron is an element. Okay, so we are going to work out the mass, okay, and that's going to be our number of moles times our relative atomic mass. So our number of moles is 0.03. Let's multiply that by 56, which is the relative atomic mass of iron, and we get that there's 1.68 grams of iron 2 plus, okay, or iron 2 in 250 centimetre cubed of solution. Let's write that in here. Okay. Now, the very last part, we're asked to work out the percentage by mass of iron 2 in the crystals. So the crystals weighed 11.76 grams in total, and in part 2 we've just worked out that the mass of iron is 1.68 grams, okay? So in order to work out the percentage of iron 2, we have the actual mass of iron 2, which is 1.68, divided by the total mass of the crystals, which is 11.76, and we multiply that by 100 over 1, and that gives us a value of 14.29%, or if we round it to one decimal, 14.3% of iron 2 in the crystals.